Hi, welcome to Kapadi Math Classes. This is your Murali Krishna. I am working as a math teacher in Roswell High School, New Mexico State and United States of America. This is the 16th video on single variable calculus and the concept is monotonic functions. In this video, we are going to discuss some more numerical examples on the concept of monotonic function. So the first example, find the minimum and maximum values of the function f of x is equal to a cos x plus b sin x plus c, where a, b, c are real numbers. A, B, C belongs to real numbers. So here the function is f of x equal to a cos x plus b sin x plus c, the combination of two trigonometric functions sin and cos. See, the calculus is very easy. If you are very good in algebra and trigonometry, most of the people, they feel that calculus is very tough, understanding is very difficult. No, it's not correct statement. If you are very good in algebra and trigonometry, solving the questions from calculus is very easy. Okay, now this a cos x plus b sin x plus c, the combination of sin and cos functions. We know what are the extreme values for sin and cos. I'm going to use that concept. Now, I'm going to convert this a cos x plus b sin x plus c into one trigonometric function. I can repeat. I'm going to convert this entire expression into one trigonometric function. Please observe the procedure. So, solution goes like this. Solution. I make this into two parts. Okay. Now, whenever you have this expression, just you take a right angle triangle, and you take the coefficients of this cos and sine function as legs of a right angle triangle, and you find this hypotenuse length using Pythagoras theorem. That is, you get a square plus b square. Of course, I'll give the name A, B, C. Now, take this angle as some alpha. From the triangle, we have cos alpha is equal to A over root over A square plus B square. And sin alpha is equal to B over root over A square plus B square. Now I'm going to use this concept in this one. So what is function given here? F of x is equal to a cos x plus b sin x plus c. Already we have a and b. If I have here a by root of a square plus b square, I can use cos alpha. Already b here, if I have b by root of a square plus b square, I can use sin alpha. So what is missing here? I multiply the entire expression with a square under root of a square plus b square, and I divide each and every term a square with b square cos x plus b over under root of a square plus b square plus c over root of a square plus b square. So I multiply entire expression with root of a square plus b square. I divided every term by root of a square plus b square. Now, in this place, I am going to substitute cos alpha. In this place, I am going to substitute sin alpha. So, this is under root of a square plus b square cos x cos alpha plus sin x So, I divided each and every term by root of a square plus b square. And in the place of a by root of a square plus b square, I am introducing cos alpha. In the place of b by root of a square plus b square, I am substituting b by root of a square plus b square. So, I will get an expression like this. So, my function turns into the form cos x cos alpha sin x sin alpha plus c by under root of a square plus b square. Okay, now if you observe carefully, cos x cos alpha plus sin x sin alpha. Again repeat, cos x cos alpha plus sin x sin alpha. You can recall an identity here. What is the identity here? We have cos of a minus b is equal to cos a cos b plus sin a sin b. I am going to utilize this identity here. This is cos a cos b plus sin a sin b. So it becomes under root of a square plus b square times of cos of x minus alpha plus c. So I converted this into under root of a square plus b square cos of x minus alpha plus c. Now I am going to find the minimum and maximum values of this expression. This is same as finding minimum and maximum value of this one. So here, and we know very well, we know that minus 1 less than or equal to cos of x minus alpha less than or equal to plus 1. I have attachment root of a square plus b square. So I multiplied every term of this inequality by root of a square plus b square. It becomes minus root of a square plus b square less than or equal to under root of a square plus b square cos of x minus alpha less than or equal to root of a square plus b square. And I have the c here. I add the c to every term. So it becomes c minus under root of a square plus b square less than or equal to under root of a square plus b square cos of x minus alpha plus c less than or equal to c plus under root of a square plus b square. So the middle one is nothing but our function f of x. So here c minus under root of a square plus b square less than or equal to f of x less than or equal to c plus the root of a square plus b square. That means for my function, the lower boundary is this one and upper bound is c plus root of a square plus b square. Therefore, this is the minimum value and this is the maximum value. So I write here minimum is equal to c minus under root of a square plus b square and maximum is equal to c plus under root of a square plus b square. Equation. Let's solution. I hope you understand this procedure. Second example. Find the minimum, find the interval in which the function f of x is equal cos x plus sin x is increasing and decreasing. And decreasing. Okay, so the solution. Now the function is f of x is equal to cos x plus sin x. I'm going to utilize the concept which we applied for the previous question. Here also my function is the combination of a sine function and cos function. So here if you compare this with a cos x, compare with a cos x plus b sin x plus c, I have a is equal to 1, b is equal to 1 and c is equal to 0. As usual, draw a right angle triangle and it takes this 1 and 1, a and b as legs of the right angle triangle, and this is 1 square plus 1 square 2, that is root 2. I'll go for a, b, c, and this as usual alpha. So here my cos alpha is equal to 1 over root 2 and sin alpha is equal to 1 over root 2. So we have to multiply and divide every term by root 2. Therefore my function f of x is equal to root 2 times of cos x 1 over root 2 plus sin x 1 over root 2. And we know very well 1 over root 2 is cos pi by 4 and 1 over root is sin pi by 4. So here substitute 1 over root 2 is equal to cos pi by 4 and 1 over root 2 is equal to sin pi by 4. When you substitute these two, my function becomes f of x is equal to root 2 times of cos x cos pi by 4 plus sin x sin pi by 4. Now cos A cos B plus sin A sin B. So this is nothing but f of root 2 times of cos of x minus pi by 4. Now instead of finding the intervals for cos x plus sin x, I'm going to find the intervals for cos of x minus pi by 4. It's very easy. Now we have the graph of cos function like this. Cos function graph. I'll start from minus pi, 0, plus pi, 2 pi, 3 pi, and so on. And this cos function at minus pi it is minus 1, at 0 it is 1. So the graph will be like this, 1, and comes down again. Cos pi is minus 1, it goes up again, down like this. So we want to find in which interval cos function is increasing. If you observe here from in this interval, this part is increasing from -1 to +1. And here is -1 to +1 increasing. So here cos function increases, cos x increases in 2n minus 1 pi less than or equal to x less than or equal to 2n pi. Here we have x minus pi by 4. Therefore, cos of f of x increases in 2n minus 1 pi plus pi by 4 less than or equal to x less than or equal to 2n pi plus pi by 4. Next one, decreases. F of x decreases. Cos x decreases in 2n pi less than or equal to x less than or equal to 2n plus 1 pi. And here is x minus pi by 4. Therefore, f of x decreases in 2n pi plus pi by 4 less than or equal to x less than or equal to 2n plus 1 pi plus pi by 4. That's the concept. So the function increases, decreases in this. Next example. Find next example. Find the minimum value of the function f of x is equal to tan x plus cot x in 0 to pi by 2. 0 to pi by 2. Okay, now solution. Now, in the interval, it's okay. The function f of x is equal to, we have f of x is equal to tan x plus cot x. And the interval is x belongs to 0 to pi by 2. That means in the first quadrant. In first quadrant, tan and cot both are positive. Okay, now to solve this question, I am going to take the concept from algebra. What is algebra here? If a and b are two positive real numbers, if a and b are positive real numbers, then their arithmetic mean am is always more than or equal to gm. Geometric mean. That means that equal to a plus b by 2 is always more than or equal to square root of ab. I am going to use this concept here. Here my a is equal to here tan x and cot x are positive in 0 to pi. So take tan x is equal to a and cot x is equal to b. So we have, this implies tan x plus cot x is always more than or equal to 2 times of under root of tan x into cot x. And the tan x cot x product is equal to 1. This implies tan x plus cot x is more than or equal to 2 times of root 1. Therefore, this implies tan x plus cot x is more than or equal to 2. Therefore, for all values of x belongs to 0 to I by 2, my tan x plus cot x is more than or equal to 2. Therefore, minimum value of this function is 2. Therefore, minimum value of f of x is equal to tan x plus cot x is 2. Next example. Find the minimum value of the function f of x is equal to 3 raised to x square minus 2 whole cube plus 8. So f of x is equal to 3 raised to x square minus 2 whole cube plus 3. Now we have to find the minimum value of the function. To find the minimum value of the function, first we need to find at which point the function attains a minimum. Once you know that point, just substitute that x value in the place here, you get the minimum value of the entire function. So that's the concept of this solution. F of x is 3 raised to x square minus 2 whole cube plus 8. For my convenience, I take this expression x square minus 2 whole cube plus 8 as some pi of x. Let pi of x is equal to x square minus 2 whole cube plus 8. Therefore, my function reduces into the form f of x is equal to 3 raised to pi of x. Now it's exponential function. It is exponential function. Now here, the point at which my pi of x attains a minimum value, at the same point f of x attains a minimum value. So instead of finding the minimum value for f of x, first I'll find minimum value of this pi of x. Okay, so here the point at which pi of x attains minimum. At the same point f of x have minimum. Okay, so I'll try to find the minimum value of this function. So now here pi of x equal to x square minus 2 whole cube plus 8. Now we'll simplify by using a cube plus b cube is equal to a plus b times of a square minus ab plus b square. Now I'm going to simplify by using this concept. Here my a is equal to x square minus 2 whole cube and my b is equal to 2 cube. So we get f of x is equal to, we get x power 6 minus 6x power 4 plus 12x square. Take x square common, we get x power 4 minus 6x square plus 12. Write this 12 as 9 plus 3. So x square times of x power 4 minus 6x square plus 9 plus 3, and this is a square minus 2ab plus b square. So I can write this as x square times of x square minus 3 whole cubes whole square plus 3. Now here x square minus 3 whole square is positive always for all values of x, and this plus 3, the entire one is positive, and this x square is also positive. Therefore this expression have minimum value at x is equal to 0. Either less than 0 or more than 0, it is going to be higher and higher and higher. Attains minimum at x is equal to 0. Therefore f of x is equal to 3 raised to pi of x attains minimum at x is equal to 0. Therefore minimum value is equal to 3 raised to pi of 0, which is 3 raised to 0, which is equal to 1. So the minimum value of the function is 1.